Hi everyone, so in this video we'll be going through the 2019 O-Level Pure Physics paper. I will be using one of your classmates' paper as a reference point for us to have some discussion on the questions and answer for this paper. Okay, so let's begin. Okay, so in this question you are given the velocity time graph. So immediately you should quickly recall that, oh okay, I can find acceleration from the gradient and I can find the displacement from the area underneath. So first question is, where can I get the largest acceleration? So like I said earlier, acceleration is from the gradient. So having one look, I need to find the part whereby the gradient is the steepest. So in this case, I think it will be around this region. So as long as I think you can get from maybe here to here, like here, it will give you a very steep gradient. So you can see that it is the steepest around here. So I think the answer, as long as you give in the range of here to around maybe here. Okay, so let me erase and let you see. So you can see this part here, it is very steep. Yeah, so as long as you give around this region, I think it is fine. So the answer should be around 1.4 to around 1.8 seconds. Now as you can see, this student actually put 6 seconds. So let's see what he is thinking. So down here, 6 seconds is actually where the gradient is 0. So actually at this point, the gradient is 0. It means that it is no longer accelerating. So I think this student, he have memorized things wrong, or that his content knowledge is not so solid, and therefore he panicked and then he put the wrong answer. So this is wrong. Okay, at 6 seconds is a equals to 0. What does a equals to 0 mean? Okay, it means a few things. It can mean that your net forces net force is 0. It means that all your forces are balanced. Or it can be talking about terminal velocity. What else can it be? Terminal velocity. What else can it be? A equals to 0. Or it could be simply called constant V. Yeah, so when you are going through your revision, you need to challenge yourself. Okay, I have this scenario, parameter a equals to 0. What can it mean? Then da. Okay, so before the exam, you should already have all these facts on your fingertips so that you won't panic. Yeah. Okay, then after that, they ask you about a statement. So the statement, I have to explain what it means when the velocity is positive, what it means when the acceleration is negative, right? And because I have a graph, I should be able to give some data to sustain this context. So when is the velocity positive? So basically, velocity is positive throughout the entire journey, right? So from because of that, I think I don't need to specify the range of time here for velocity is positive. But for acceleration is negative. Acceleration is only negative when the gradient is negative. So I can see that it's around here when the acceleration is negative. So when I am explaining the statement, I may want to include things like, oh, it is from t equals to maybe 8.2 to around 9.8, right? This is when your acceleration is negative. And why would I want to do that? Because actually there is this term here, sometimes. So in order to explain the statement, I also need to address what it means by sometimes. Okay, so that when I read the question, all these things will be already in my mind. So now let's look at what the student write. When acceleration is negative, it implies that the athlete is slowing down. Yep, very good. It addressed what it means by acceleration is negative, but unfortunately, the student didn't talk about sometimes. When does this happen, right? So down here, how would he improve on his answer? So making edits to your wrong answer is more important than you are copying down my answer. Okay, because by editing and improving your answer, it shows that you interpret it and you internalize it. So one way is instead of saying when, you can say like a statement. So down here you can see something like at time equals to da 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 to da da da, which is this time over here 8.2 to 9.8. So you can say between, instead of at, it will be better if you use the word between, right? Time equals to 8.2 to 9.8 seconds. Remember, always with unit acceleration negative da, da, da. Okay, so it will be 1 mark over here, but because the student didn't put in the time, so I guess this one is half a mark, and then finally what negative acceleration means is another half a mark. Yeah, then after that, but due to the large positive acceleration, all these are unnecessary. So basically now the student is self-penalizing himself on all these unnecessary things, and to the marker it also shows me that these students are unable to actually pinpoint what I want from the question statement. But I won't penalize marks from him because he already self-penalized in terms of time. Thus, the negative acceleration caused the athletic velocity to decrease, but still, you see, all these things are pointless. He didn't talk about what it means by having a positive velocity. So all the things at the back are irrelevant and he couldn't capture the mark. So what it means by velocity is positive. So if I were him, I will put down here, I need to explain what it means by v more than 0. So what it means? It means that now you are moving away from the starting point. You are always traveling in one direction, right? So the correction is when v is positive, please don't use things like that. I'm using that so that I don't need to write so much. When your v is positive, it means a few things, that you are moving in the positive direction and you are moving away from the starting point. So why is it important that I add in the second statement, moving away from the starting point? Because it relates to the context. So because this context is about an athlete in a race, so it means that, is this track a circular track? No, right? If it is a circular track, then maybe I'm going back. But with velocity is always positive, it means that I'm always moving away from the starting point. Okay, but I think the marking scheme shouldn't be so strict. As long as you say that it is always moving in the positive direction, I forgot the word always, you should be able to score 1 mark. Yeah. Okay, state how the student shows that the race is 100 meter long. So again, very good. You are reading the area under the graph. If I am being picky, then please let me know from time equals to what to time equals to what. Okay, but I think he will get his 1 mark. Okay, so this is 0, I forgot. Determine average time, very good. Put the statement first, so already state half a mark. Then he will need to interpret data. This is 100 meters, so very good. Total time is 9.8, so he got the data from the graph correctly, and then after that he processed the data correctly, so a total of 2 marks is given. So that is for your question 1. Okay, for question 2, just by looking at the diagram, we know that it is about moment, it is also about stability. Okay, of course, it is also about CG, and also you need to know that the weight is always at the center of gravity. So just from the first line of the context, you already know that the weight will actually act at G. So this is where your weight is. I think the question also mentioned that it is swinging about a pin through A. So you know that actually at A, you can see that they use the word about also. Moment is always about something, the pivot about where. So down here, you know that your pivot is actually at A. So down here, this guy is actually your pivot. So just by reading the first line of the context and looking at the diagram before the exam, during your preparation, you should train yourself up to a stage whereby one look at the thing, you can quickly decide, okay, it's about moment, it's about stability, it's about CG, the pivot is here, the weight is here. Quickly form all this in your mind. Okay, for 2 part A, please refer to your textbook and then correct yourself. I won't be talking about this. After that, they gave you several dimensions. just be very mindful whenever they give you the mass, check whether this guy is in kg or in gram, because as you can see down here, tricky thing, your gravitational strength is per kg. So actually you need to change this to kg first, and this student managed to do it very good. Yeah, so definitely there will be some mark given. And he turned the mass into weights because only forces can give rise to a moment. So definitely there will be 0.5 given here, there will be another 0.5 given here. Then he gives the statement, because you are asked to find the moment. This statement is important, so definitely I will give him marks for that. And then he states his formula. So I think just by this you will earn your half a mark for writing the statement and the formula. So now is that he need to choose whether he picked the right distance. Down here, this is very bad presentation, and it is no good for your checking. If your F is over here, then I would expect this number to represent the excuse me, I will expect the number behind the parameter to be the value of that parameter. So it is better for him to actually write down 2.5 bracket 0.3. So let's check whether the student has picked the correct distance. So go back to the diagram. This is the weight. So for me, I always go by step. This is the line of action of the force. This is the pivot. The distance is the perpendicular distance from the line of action to the pivot. So the distance should be 0.3. So just remember to check, is your 0.3 in meter. So very good, is at 0.3 is at the meter. So he got everything right. Unit is correct. It is up to 2SF. Everything is correct. He will get the final 1 mark. Okay, so in total he will score 3 marks in total. Part C. You have to explain why it eventually stopped. So I have already mentioned that if it eventually stopped, it means what? It means that your Fnet is 0 and your Mnet is 0. So depending on how much marks are given, you may or may not want to include Fnet, or you may or may not want to include Mnet. So just by looking at this, it's just 1 mark. So I think in here, since the first part of the question is on moment, I will just include moment. That's all. I will not talk about Fnet. So now I need to explain why eventually Mnet will become 0 when point G is below A. So what they are referring to is that they are saying that, okay, I will have a case whereby my pivot is here, this is my A, and then it will only stop moving when my CG is right below. It will stop swinging. So why? As you can see, if I do the same thing, you can see the line of action is here for the force W. You can see that there's no more perpendicular D. So the key thing about here is that because there is no more perpendicular D when my point G is below A, then I would have Mnet equals to 0. So when Mnet equals to 0, it will stop swinging. So in my mind, I will quickly form this structure in my mind, and then I will verbalize it, and then I will write it down. So let's see what the students say. When the object is at this position, so I think at this position refer to here. So okay, fine. There's no net moment. Very good. This is the key thing. So once I see this, I know that, okay, he knows his stuff. So let's see how he elaborate and relate to this. No moment acting about the pin, Okay, very good. So up till here, it is correct. Perpendicular distance between line of action of the weight and the pivot is 0. Very good. Thus, there's no moment. Very good. Full mark. Okay. So that is for question 2. Now let's look at question 3. Question 3, just by looking at this, I know it is about energy, right? So down here, how do I know it is about energy? Okay, it may be about kinematics. But in your kinematics, we are dealing with one-dimensional motion. One-dimensional motion means that it has to either move along left to right, up and down, along a line. That is one-dimensional. So in this case, you can see there's a curve. A curve is actually two-dimensional, right? So because of that, I know that, okay, it cannot be kinematics. So what else? Oh, maybe it is about forces because there's air resistance. But again, in your forces, you are dealing with one-dimensional stuff. So because of that, once I look at it, I know that, okay, it has to be the three energy that we are talking about, GPE, it is about KE, and sometimes it could be about work done. But in this case, since I know that air resistance is negligible, it means that most likely my work done I no need to consider. Okay, so let's look at this. At point A, the ball has kinetic energy. Point B, I have both GPE and KE. State what is the meaning of it. I think you can do that. Kinetic energy processed by the object. I think this one is from your textbook, so I'm going to skip part A. Let's look at the part B. Part B, metal ball, speed is both are in SI unit, so it saves you the trouble in conversion. So quote the formula, very good. Sub in the right value, looks cool. Okay, full mark, 2 marks. Then after that, it says that the kinetic energy at B is 180. So just remember, the diagram looks like that. At the very beginning, you have all your energy, which is equals to 300 joules, and that for B, where is B? B is at the top right here. So it says that at B, okay, there's some KE over there, which is 180. So you can see that the number doesn't match, and it means that the remaining energy must be your GPE. So very good. GPE is here, full mark, 1 mark over here. Change in vertical height. So basically the gain in GPE, which is here, oops, sorry. The gain in GPE over here will give rise to the gain in height. So very good, give the formula, sub in the right value. Okay, very good. Okay, 2SF, poor thing, like that, don't have 2 marks. And this guy always have problem with 2SF, and that has to do with his daily routine, whether when he do this kind of practice paper, whether he has a habit to check, because by checking, you will then develop this awareness of 2SF. Why is it that I can spot it so quickly? Because I mark 40 scripts, 44 scripts sometimes. So it has been internalized. So how do you get this skill? Of course, you can always come and help me mark, or when you are doing your paper, after you do your paper, you exercise checking. A lot of you don't exercise checking. Okay, so that is your question 3. Okay, your Q4, just by looking at it, you know that it is on KMM, kinetic model of matter, and in kinetic model of matter, we are basically talking about temperature, pressure, and volume, how each of them change each other. So it is like a relationship triangle. So in this case, you already know that temperature is being kept constant, so you don't need to talk about change in speed of molecule because it is kept constant. So basically what happened is that you keep one end sealed, and then you press the piston in, and as a result the volume will actually decrease, and as a result pressure will increase. So you are supposed to use ideas of molecule. So basically you need to talk about collision frequency between particles and the wall, and then you need to talk about maybe number of particles per unit volume, and then of course you need to quote the formula P equals to F over A. So let's take a look at what these students said. Piston is pushed forward, number of air molecule per unit volume increase, very good. Causing increase in collision frequency, very good, between air particle and the wall, very good. By P equals F over A, F increase, A decrease, pressure increase, excellent, excellent. Okay, he repeat the thing, and this time round he used water instead of air. So between water and air, what is the key difference? Water is liquid, air is gas. So one is compressible, the other is not. So just by reading the context, you need to quickly pick up the key differences. He applied the same force, volume of water doesn't change. Why is it so? So in another word, they are asking you, why is liquid incompressible? So whether something is compressible or not depends on 2 things. One is there space between them available for compression, and number 2, is there a very strong resistive force to keep the space open? Yeah, so in water is a liquid, very good. He pointed out the key difference. Molecules in the liquid are closely packed with very little space, very good. So he didn't stop at closely packed, but he actually zoomed into the key thing, which is the availability of the space, right? Okay, the lack of large space make it incompressible. So he forgot one point. So between them and, so this one no need. Okay, he can just say that and there is strong intermolecular force between the molecules. So the lack of space plus this strong repulsive intermolecular force makes liquid incompressible. Okay, so this is the key thing that he forgot. Okay, let's move on to calculation. So very good. I can see that he already established the reference line. So he's comparing left hand side to right hand side. So on the left hand side, it is just the pump pressure. So very good. On the right hand side, there will be pressure from the atmosphere plus the pressure from the liquid column. So liquid column, atmosphere, very good. And expand into the right formula. Let's see whether he sucked in everything correctly. Pressure from the pump, very good. Atmospheric pressure here, very good. And then rho, very good. SI unit, G, okay, good. And finally he does his math correctly. So everything is correct. 2SF, very good. Full mark. This is question 5, and just from the look of it, we know that it is on the chapter of sound. So definitely there's a cliff and then there's a source of the sound, which is the student. So it looks like it is a case whereby the sound is emitted towards the cliff and then it bounced back. So when you see such setting, you would know that the distance travel is actually 2 times, because the sound would need to go out 1D and then bounce back. Okay, so quickly, once you see this question, quickly you need to form this in your mind. So it says that as it stands at the position in figure 5.1, the echo actually takes 3.6 to come back. Okay, and then after that, I think for this student, the way he drew the distance is not very good, so it should be from here. So I guess this is the distance for the 3.6 seconds, and then after that she walked to here. That distance is 200 meter, and then he sent out a sound again, but this time the sound of course will reach her at a shorter time, because now he's nearer to the reflecting surface, which is the cliff. I have to calculate the speed using this setup. So let's see what he did. He wants to find the speed of sound. So I do not know why he decided to find D, but let's read what he does. What he did. Let original distance be D. Okay. Time taken to travel D, which is a 3.6, but 3.6 is for the sound to go like that and come back. So it's actually 2D. So he did a great job. He divided the time by 2, so these two are correct. Time taken to travel, distance minus 200, very good. Speed to travel 200, time to travel 200 meter will be this. Okay, so he find the sound, the time to travel this distance, so that's okay. And then distance over time. Okay, fine, good. This method is alright, so full mark, 3 marks. Let's look at the structure question. State how the sound heard changes when the amplitude of the sound decreases. 1 mark, 1 line. So I would 1 mark, 1 line. So I expect the answers to be short. So when the amplitude decrease, the sound becomes softer. Very good. Wavelength decrease. Wavelength decrease. We will need to think about it. So what is the thinking process? So wavelength is given in this formula. I know that the speed of sound in the medium air will be the same. So it will be, speed is constant. And now since the wavelength decrease, so this guy has dropped. So when the wavelength has dropped, and to maintain the speed as constant, it means that my frequency must go up. When my frequency goes up, then the pitch of the sound will become higher. Very good, excellent. So 1 mark each. This is question 6. I have 2 resistors of different resistance connected to a battery. Insert electrical quantity in the gap in each of the sentence. So fill in the blank. When resistor connected in series, what is the same? The current is the same. When it is in parallel, potential difference is the same for two resistors, so it's fine. So free 1 mark. Resistance of resistor in series with a thermistor. Okay, so you are supposed to draw the symbol of a thermistor. This is correct. You can also draw it this way. You can draw it this way. You can draw it many ways. You can even draw it this way. So all of these are correct. Okay, so this is 1 mark. Room temperature between X and Y is 1.4. So it says that if it's like that, I will get 1.4 volt at room temperature. Calculate resistance of the thermistor. So I'm given the EMF, and then after that I'm given this. So there are many ways you can do. You can combine the circuit into one whole chunk of stuff, and because you know the EMF, you can actually find out the main current. Once you find out the main current, you would know that the current going through here is how much, and then apply V equals to IR to your thermistor, and you can find out the resistance of the thermistor. Okay, so let's see what this student does. Let's see, PD across the 1000 ohm resistor. Oh, okay, 6, which is the EMF, and since down here I use 1.4, I would know the PD over at the 1000 ohm. So okay, by V equals to IR, current for the circuit. So okay, so I think looking at the value sub into here, he's applying this to the 1000 ohm resistor. Okay, so he will get the current flowing through the 1000 ohm resistor, which is also the current of the circuit. After that, he apply, I think this person very confident, but okay, it's a he will tend to be overconfident. He will fumble somewhere. Okay, apply V equals to IR to the thermistor. Okay, so here rearrange the formula. The V for the thermistor, the PD is 1.4. Current will be current of the circuit, and then he found the answer. Okay, good. For question 7, it is just by reading the first line, you would know that it is about energy, and it is interesting because it talks about this thing about renewable energy. So like I said, in our lesson, we don't cover everything in the textbook. You need to read your textbook. That's why we ask you to buy it. So renewable energy and non-renewable energy is actually mentioned in your textbook. There's a lot of content there. You will need to read it. Okay, so you have to name one other renewable energy source. Wind energy, okay, from the wind is okay. You can talk about geothermal, using the heat from deep underground. There are many other renewable energy sources, so please go and read about it. Okay, so this is a good example showing you that Cambridge like to pick out small pieces of content from the less popular portion of your textbook. So then B is about your solar panel. So usually solar panel is about heat transfer question, but this time around they turn it into a practical electricity question. You need to know how to calculate kWh and so on and so forth. Now pay attention, this energy output has already considered energy loss, things like that. Okay, so it is already averaged out. So you are asked to actually calculate how much saving your solar panel can offer to you, and when will it balance off the installation cost. So the installation cost is given as 6,000, and basically your solar panel will be generating electricity for you, which is worth $0.26. So now you can see what the student did. Money paid each year. Money paid, I think what he mean is money earned. Okay, so as you can see, this student is really not very careful with the choice of word. But anyway, money earned each year, 1,005 already in kWh, so you can use the value given. That will translate to a dollar value of $0.26. So every year, your solar panel is actually generating energy that is worth $390. So if you want to cover a cost of 6,000, you divide it, and I think you should round it up, right? How do you get 15? So just let me do a quick check with the calculator. I remember it is not 15, so 6,000 divided by 390. 6,000 divided by 390, it will take 15.4 years. So in order to cover the cost, you need 15.4 years. So 15.4 years, meaning that you need at least 16 years to cover the cost. Okay, so this time around, it also check whether the student is sensible to actually round it up higher, round it up rather than round it down. Okay, so this has to do with your mathematic concepts. So anyway, I already mentioned that he is careless in this kind of thing. So you have to state one assumption. Energy output from the thing is constant at, okay, correct. You are assuming that different year may have different energy input from the sun, and if you have different energy input, then your energy output will be affected. Another assumption that I can think of offhand is that the worth of your energy may change over the years. Some years the energy may be cheaper, some years may be higher, and then of course $6,000 15 years back and $6,000 now, the value of $6,000 will be very different. So you have all heard from your grandparents that $1 I can get a chicken rice last time, but now I need to pay like $2 plus. So the dollar has different value over the year. It may depreciate and you know, things like that. So you can talk about this as an assumption. Okay, now they test you on your understanding of efficiency, about 15%, so very good. This part I need to praise him because he always write down his starting formula. So that's the correct formula. You have 15%. The output is given as 15 kWh, which is here, so he back calculated that. I hope his math is correct. Not sure. I think okay, as long as he does 15 100 divided by 15%. If that tallies, then he will earn that 1 mark. Suggest, what happens? So when you see suggest, as long as you give a sensible answer, you will get the mark. So I think this is sensible. There are 2 lines. So you may want to extend. Let's check the Marcus report and see what they say. Okay, so this is question 7 part 2. Let's see what they say. 7 part 2, Marcus report, physics 219. Oops, question 7. Okay, majority of the candidate give an acceptable explanation in terms of heat loss. Statement that energy is converted to other form was considered too generic. I think heat is kind of generic. Stronger performing candidate states that some of the incident energy was either converted into thermal energy, which is the generic one, or was reflected. Okay, so it seems that it would be safer to not just say that the energy converted into heat, but you can say that some of the incident energy from the sun is reflected away or absorbed by our atmosphere. Okay, so I think that would make it a better answer since they give you 2 lines. Okay, let's look at your question 8. Question 8, just one look from it, you will know that it is about electromagnetism. You will have a coil. Once you see a coil, you quickly think of, okay, magnetic field. Yep. So on 8.1, I'm supposed to draw a pattern of magnetic field. So let's look at it. The general pattern is symmetrical, very good. I can see the line of symmetry right here. I can see arrows. And using your right hand grip rule, I can see that the arrows are correct. It will be pointing like this. I'm just drawing it out because it is not very clear from the pencil, but generally it is correct. So I think I will give him a full mark of 3. State the effect of this magnetic field line of having larger current. Magnetic field line would be more concentrated in the solenoid. Okay, very good. Okay, more concentrated, it is good, but it will be best if you can say that it is more concentrated and more parallel or uniform inside the solenoid. So it is not just more concentrated, but it's more uniform. A uniform field means that it is very strong. Okay, concentrated is one, uniform is the other one. So it is 1 mark, 2 lines, so it won't hurt to just look at the Marcus report and see what they say. I think it's B. Candidates describe the effect of the field line. Some candidate merely state that there will be a stronger field, okay, but didn't relate to the magnetic field line. So what it means is that the candidate just say that, oh, the field will be stronger, but unlike the student that we see here, okay, he has described, right, how the lines will look like more concentrated. So I think it's good. Let's read on. Number of answer is big, describing as a larger or more spread out. So I think this answer will be sufficient for the 2 lines. Okay, each of the magnet, how it looks like. So A attract B, can't really tell. Okay, so let's give some dummy pole. Let's put this dummy pole here. So attract cannot conclude anything. Attract again B, that means down here I can induce self. This kind also the induce self, so it means that your B is just maybe a magnetic material. Okay, that can be induced anyhow. A and C it attract, so meaning that this is south, and then so meaning that this will be north. And okay, so it repel means that your C is definitely a magnet, right? Having said that, it also means that because of this repulsion, my assumption that A is a magnet is valid. Okay, so A is a magnet, C is a magnet, B is unmagnetized iron. I love the way he said this, unmagnetized iron. Explain in your answer. B is attracted to A even though B was flipped. I think this is not a very good expression. You can say that both ends of bar B is attracted to bar A. However, bar A and C repelled. So as like pole repel, bar A and C are permanent magnet. Okay, excellent. As what? Okay, yep. So 2 marks. Okay, so this is question 10. So question 10, remote control uses infrared, which is correct. Remember in your sunbed, I made the mistake. I thought it was infrared, but then later I realized that it is ultraviolet. Make sure you spell violet correctly and not violent. After that, you are given a thermal property question. You have to use your Q equals to MC delta theta and things like that. So you can see that a beaker contains water at its boiling point. So at its boiling point, it means that it has already reached 100 degrees centigrade. And the energy absorbed by the water is 45% of the input energy given out, supplied to the oven. So basically, the water is receiving energy given out, emitted by the oven. You are given the specific latent heat of vaporization. So this guy over here is small LV. So I need to calculate the mass of the water that turns into steam within 120. So why am I having 120 seconds? That is because I know that for the oven, it will give out 850 joules per second. So this is what the W means. And I know that this is input, so I need to translate this into the output. And how do I do that? I need to look at the efficiency, which is 45%. So this output most likely will be 45% of your 850 joules per second. Okay, so now I know that I will heat up for 120 seconds. So the amount of energy that I will have will be multiplied by 120 right here. So that is that. Let's form the equation. So basically what I'm writing here is that the energy emitted by the oven will be absorbed by the water to change its state. So that's why I put large LV, which stands for latent heat of vaporization. There is no Q component here because the temperature will remain constant at 100 degrees C. So what I'm doing here is the 45% multiplied by the power, the input power of the oven, and I am only heating it by 120 seconds. So this is my input energy. This energy given out, sorry, it's not the input energy. This energy given out by the oven is absorbed by the amount of energy that, the amount of mass that has turned into steam. So that is the M. And then of course I would have my latent heat of vaporization. Do your math, change it into 2SF. Here you go, you will get 3 marks just by doing this. So it's quite straightforward. Okay, for part C, again, this paper really picks on the unpopular, not less popular part of the textbook. You need to go and refer to your page 147 to actually find out what is the harmful effect of X-ray. So we found these 3. We do not know whether it is correct or wrong. So this is what we want to suggest to you. Yeah. Okay, then it is the either question on forces. So for 11A, you need to talk about the effect of unbalanced force. Unbalanced force simply means that your net force is greater than 0. So when you are having a great net force greater than 0, first of all, your object will accelerate because by your second law, F net equals to ma. So if your F net is more than 0, definitely your A will be more than 0. And you need to extend it and let me know that your direction of your net force acting on the object is the same as acceleration. So the second part of your Newton's second law is that your F net and A must be in the same direction. Okay, so this is 2 mark and 3 lines, and you can see the effects. So there are 2 effects. So let's take a look at the report for question 11. So let's go to question 11. most candidates mention that it will cause acceleration or deceleration, okay? Candidate discuss first law in detail, often giving detail more than necessary. So that's why I didn't quote it. Candidate often overlook the fact that the direction, you see, you need to talk about the direction of the motion of the object, okay? Yep, so I think I cover most of it. So it's the 2 points. Number 1, it will accelerate or decelerate. It's fine if you mention accelerate. Number 2 is that don't forget F net and the A must be in the same direction. Okay, after that you are supposed to draw the free body diagram. Always remember, tension is always acting away from the object and it is along the rope, so you can draw on the rope. Please do not draw things like, if this is the rope, you draw the force outside. This is called floating force, no such thing. Okay, after that, there is his feet is on the wall, so there will be normal contact force. Remember to draw your perpendicular symbol. Okay, and of course you need to label your forces in full name. Okay, you have to state the name. Okay, after that, they actually check on your Newton's third law. Always remember, Newton's third law means if there's a force from A acting on B, then there's this thing called action-reaction pair. So the action-reaction pair would be the force from B on A. Okay, so you can see that this thing here is always swapped. Okay, so here it says, teacher states that figure 11.2 does not show an action-reaction pair. Why? The weight of the book is from the earth acting on the book, right? The reaction force, which is the normal contact force, is from the table on the book. So you can see here the symbol is not the same. Both of them are acting on the book, so they are not action-reaction pair. Okay, so that's why the teacher is correct. State 2 way in which the force is an action-reaction pair. So number 1, they are action-reaction pair if the magnitude is the same. So if FAB is 10 Newton, then FBA must also be 10 Newton. The other thing is that if FAB is in this direction, FBA must be in the exact opposite direction. So the second similarity is that the type and nature of the force has to be the same. Okay, but this answer is a bit vague. A better answer will be that this force will be acting along the same line of action. What does it mean? Can you see that if my 10 Newton is to the right, my action-reaction pair will be to the left, but they will be along the same line of action, the same dotted line. Okay, so this will be a better answer. This one a bit weaker, not sure whether they will give it or not. The difference is much easier. Of course, the direction of the force will be exactly opposite. The other thing is that the object that the force act on will be different. So what do I mean? FA acts on B, action reaction, B acts on A. Can you see that it acts on B on one, then it acts on A on the other one? Okay. So for example, if I want to know the action reaction pair of this guy, the action reaction pair will be the force acting by the book on the earth. So can you see this one is on the earth, this one is on the book. So this is action reaction pair. Yeah. What is the normal contact force action reaction pair? Well, action reaction pair will be normal contact force, the book acts on the table. Okay, so you can see that one acts on the book, the other acts on the table. Can? So that is what this means. Okay, for your part 3, Earth exert a force of 10 Newton on the book. This is one force in the action. Describe the other force. So when you describe the other force, you always describe a vector in terms of its magnitude and its direction. So you need to talk about the value and the direction. So the book exert the value 10 Newton of the force on the earth, right? That is this, right? On the earth in the opposite direction. So you need to talk about the magnitude, the direction, and because this is a force, you need to be better to say that it is from the book on the earth. Okay. Okay, last question is on optics on your light. So you need to describe how do you use a projector to determine the critical angle. So number 1, you need to know that at the critical angle, what you will be observing is that you will notice the emerging ray is along the boundary. So how do you determine an angle? You need to shine a beam of light in until you get this yellow highlighted beam along the boundary. So first, you need to identify what is the angle that you want to measure, which is your ditter here. You need to label it, okay? And then you need to tell the reader when are you going to shift this light. You are shifting this light, right? When do you stop shifting it? Okay, so this is what I suggest you to do. Okay, adjust so the keyword used is adjust incident ray such that the angle theta, such that at this particular angle theta, the ray that is emerging from AB is along AB, and then identify that this particular theta will be your critical angle. Okay, another way of doing it is, of course, you just shine any ray into the glass, but in this option, you measure the angle of refraction, and then you apply your Snell's law to find the N, and then from there you find the C. So it is a bit leche, but you can do that as well. Okay, so next you will need to know that the light from the sun actually consists of the whole range of your EM spectrum, including infrared, ultraviolet, so on and so forth. And inside your visible light band, it consists of different colors. And all these waves from the EM spectrum, when it enter into a different medium, it will slow down by a different amount. Okay? You can play with the Snell's law and find out how which one will bend more, which one will bend less. Yeah. So let's take a look at this question. I have to draw a label and all that. So this is how you label it. The red light. So this is your red light. I have to label what? Angle of incident and the angle of refraction. So I have already labeled it here and here. Always measure from the normal. So how do I draw this normal? So first, you will have the light ray. You will identify where's the point of incident. Then after that, you draw your tangent. Okay, the tangent is quite by guess. It's like roughly. You need to make sure that this angle and this angle is about the same. You need to make sure that your tangent only cut the curve at one point. Okay, so if let's say I want to draw a tangent here, if I draw it like that, this is wrong because I cut the curve at another point. Yeah, so I have to draw it until I cut the point, I cut the curve at exactly one point. So that is how you draw your tangent. So once you draw a tangent, you can draw a normal, which is a 90 degree from the tangent. Then after that, you can draw the two angles, label it, and you will get the marks. Yep. Okay, refractive index of blue is slightly higher than the red light. So what you can understand from here is that N equals to C over V, right? C is a constant speed of light in vacuum. So basically you can think of it this way. If you have red and then you have blue, right? What you are having here is that N equals to a constant over V. So they are saying that N of blue is high and then this one is low. So if now you make V the subject, you will get constant over N. So if you have a small n here, it means that the V will be higher and then this V will definitely be lower. So maybe I don't use the arrow, I use the word high and low. So I will have high V, this one will have low V, and this V is in the medium itself, right? So what does this tells us? If you imagine that you are marching in a column, okay? So let's say this column, this is the medium, okay? And then down here, it is your air. So as your column go in, let's say you have wavefront like that, right? At this point, your wavefront, this wavefront here is still moving at normal speed. So let's say this normal speed is 7. When it goes into the medium, if your light doesn't slow down that much, like your red light, it is still moving quite fast. Let's say it's still slow down to maybe a 5, then if this part here will bend a bit like this, right? Correct? But maybe I use red. Yeah. But if let's say it is blue light whereby it dropped to a lower speed, so let's say it dropped to a speed of let's say 3, then of course it will bend even more. So we know that when we have a relationship like this, what we know is that the bending for your red light will be less, but for your blue light it will be more, it will bend more. So how does it look like? So once you understand this, your red light will bend less, right? So what does it mean by bend less? This is the original path of light. Original path of light without bending is like that. So if it bend less, your red light will be here, your blue light will bend more, so it will be here. Understand? Yeah, so that is what it means by bend less and bend more. So let's look at the question. State and explain how angle of refraction at point B for blue light compares to red light. So first you can quote that the refractive index is different. Then you can say that it slows down more for the blue light, and because it slows down more, it will bend away. Please quantify bend away from where. So it bend away more from the original path, and so you refer back to the subject of the question, which is angle of refraction. So this is just one mark, but you need 3 lines. Okay, then after that you need to draw. So I'm assuming no total internal reflection, so I'm just assuming then it will get out, because I don't want to calculate all these things. So I just assume, and then I just write down it gets out. Because the red I think is draw for you already. So you go here, you will have a much smaller angle of incidence here, so I assume no TIR and it goes up. Yeah. Okay, after that it is a calculation kind of question. You are given the frequency, you are given the speed, or in SI unit, you are given the refractive index. So just use your formula, n equals to C over V, sub in the value, n is 1.5. Okay, this one is right here. So once you do this, you will be able to find the V. Yeah. What am I doing? Oh, okay. So down here, I expand it into my wave formula. So V become F lambda, I got this, and then I substitute in this. I skip a step. Basically, I move this over to here. So that's why 1.3 appears like that. So after you calculate, you get this, you get this. You can leaving it in standard form is easier for me, but you can leave it in this way. You can leave it in this way, and you have to be careful with the number of 0. This way is also fine. Of course, it's in meter. Yeah. So I think that's it for your 2019. If you still have questions, please feel free to come and look for me. I will help you. Yeah. Okay. See you.